Middle East and Africa. I'm Joumanna Bercetche in Abu Dhabi today for the ADIPEC conference. Now, artificial intelligence is radically and rapidly transforming the energy sector. Advances are being seen across exploration and production, as well as more efficient drilling and managing of renewable energy sources. SandboxAQ has released a quantitative AI model focused on discovering new catalysts for energy, chemical, agricultural, and other applications. To dig deeper into this, Jack Hidary, CEO of SandboxAQ, joins me right now. Well, I can't think of a better person who's uniquely placed to talk about the intersection between artificial intelligence and energy. That's a big theme here at ADIPEC this week. And
Joumanna, great to see you.
Yeah, good to see you too. So just talk to us about the extent and the scale of the opportunity that you see in this space right now.
Well, it's really fascinating. 99% of the AI that our viewers here are familiar with, ChatGPT, Google Gemini, wonderful applications of AI, but that's AI for the digital world. Now we're talking here at ADIPEC about AI for the physical world. And that's the AI that's really going to impact the energy industry and all of the consumers of energy around the world.
So what does that mean exactly?
So let's talk about, for example, when we take oil out of the ground, and many of the companies that do that are right here at ADIPEC, what happens to that? How do we turn it into useful products, both fuels and products that we can use? 80% of all the products that we use in our world come from the hydrocarbon cycle, come from these kind of companies. And so we need something called a catalyst. A catalyst is a chemical that helps us turn raw product into finished product. And to make catalysts, it's really difficult. On average, it takes about 5, 10, sometimes 15 years to make a new catalyst. Those are essential ingredients to making all the goods in our world. The cars, the chairs, the pens, everything you use in our world comes from using a catalyst. And now with our AI that we just announced last week with NVIDIA, this is an AI that is the best AI, the best model in the world to make a new catalyst for the energy industry.
So what is it specifically that you're doing differently from your competition in this space?
Great question. So instead of training on words, so large language models are trained on all the words of the internet, and that's great if you want to write an essay, if you want to summarize a document, marketing, customer service, great applications for large language models. We're one of the leaders in the world of large quantitative models, meaning that we don't train on words, we train on numbers, equations, and molecules. And this is a very different training set, and therefore a very different model. And what we've shown now with NVIDIA's help, one of our investors, is that we can now produce catalysts at much faster speeds and also speed up other areas of the energy industry. An example is when you look at the fluid dynamics, the flow of fluid inside of a reactor as it's going through the refinery, we have sped up that process as well. So AI for the physical world is now going to be the next revolution of AI.
Yeah, and what sort of productivity or efficiency gains are we targeting here, right? Because one of the criticisms of AI is there's been so much spending on AI applications, but perhaps many companies are still not getting the return on investment.
That's absolutely true. An MIT study just came out that 90% exactly of the, and that's because, again, large language models are really good for some things, but not for all things. I'll give you another example. We talked about the energy industry here at ADIPEC, but also let's talk about the banking industry. Banks, it turns out, deal with numbers and equations. And large language models can be helpful in a bank, for example, to summarize some documents from the SEC or things like that. But the majority of what a bank does is numbers. And we cannot have any kind of hallucinations when it comes to the numbers in your account. Your account matters to a bank. It should anyway. And so we have to make sure that is exact and precise. That's the domain of large quantitative models. Models based on numbers, trained on equations of quant finance in that case, or in the case of energy, trained on the physical laws to make new chemicals for the world. So these are very different models. We don't have any hallucinations because we use pristine scientific data instead of the words of the internet. That's a big fundamental change, and that speaks to the issue that the MIT study
And ostensibly, you're also dealing with troves of data that go back decades, right? You're talking about, Aramco, ADNOC. These companies are sitting on decades and decades of data specific to the energy industry, specific to the type of data that's going to inform your models better.
With that kind of data, you do not want to feed that into a language model. That is very different kind of data. And even when you talk about biopharma, biopharma is in the same kind of ballgame where if you look at Sanofi, look at Roche, they want to develop new drugs. That's not really the large language model to do that. That's, again, an AI for chemistry and biology.
How do you see quantum computing coming into this in coming years?
Well, quantum now is really starting to get in people's minds, and that's very exciting because quantum computers will add to the mix. A quantum computer fundamentally is different than the computers we have. It's not just faster, it's a different kind of computer altogether. The good news is there's about a dozen companies out there right now, both large companies like Google, IBM, Amazon, Microsoft, as well as a lot of startups such as Quantum and others, QEra is another one, that are now rising up. And I think in the next 5 years, we're going to see significant progress on the part of these quantum computers. SandboxAQ, we write the software that runs on top of those quantum computers. And so it's an exciting coming together now, a convergence of the software algos and the hardware.
Yeah.
But we may also want to talk about the cyber aspect as well to all this.
Yeah, well, I mean, obviously there are cybersecurity concerns. How do you think about creating a system that is bolstered and immune to those types of shocks?
Joumanna, this is a fundamental issue, particularly here when we talk at ADIPEC about the energy industry. Energy is a critical national infrastructure for every country in the world. We cannot exist without energy. And so we must protect, from a cyber security perspective, the energy, the power generation, the electric grid itself, the usage of all this, the management of all this has to be protected. We know that there are state actors and other hackers that have penetrated into the electric grids in the United States. We know that's happened for sure, and probably happened in other places as well. AI is both a great tool for hackers, but also the tool we need to defend against these hackers as well. So AI is really a dream tool for anyone wanting to go into a certain area. For example, for phishing, they can write a beautiful email, "Dear Joumanna, please click on this wonderful link." And that's a great threat right now. And so energy companies and national companies as well need to really think about how do they defend themselves against this. And the best way to defend yourself against an AI attack is AI itself that can look at that attack, detect that attack, and stop it in its tracks. 4 or 5 years from now, we also have to worry about the quantum attack. That's also going to be something 4 or 5 years from now. But right now, we've got to worry about the AI attacks.
Jack, so interesting. Really good to chat to you. That was Jack Hidary, SandboxAQ CEO here at ADIPEC.